Hello, welcome. I'm Jerome Dochez. I'm a software engineer at Google.
I'm Chris Warrington. I'm also a software engineer.
And I'm Isa. I'm also a software engineer.
Hi, guys. I'm Leo. I'm a product manager. And so we're here to talk about the Gradle plugin. But first, I wanted to talk about build speed. You probably heard from Karen this morning. We recently looked at our data and had some interesting findings that I wanted to share with you today in all transparency. The metrics that you're going to see comes from developers who opt into sharing their data with us. So if that's your case, thank you very much. All right. So first, we looked at build time change a little bit across a couple build times before and right after an Android Gradle plugin upgrade. And so what you see here is the median improvement in speed in percent. And you can see that outside of a minor regression in 3.1.2, we've been pretty consistent at 7 or 8%, and even 20% with 3.2.0. So we thought, OK, if everyone upgrades to the latest 3.2 or the latest release, build speed should be getting faster and faster, right? Well, not exactly. Turns out that when we looked at build speed over time, it is getting slower and slower. And I don't want to call this the build speed conundrum, but it got us a little bit puzzled. How is it possible that on one end, we keep improving with every release, and on the other end, we keep seeing build speed get slower and slower? So after some exploration, we realized that the build ecosystem is very complex. And I'm a new guy in Android, so I can tell you it is very complex for me. And it's rapidly evolving with so many things that can impact your build. For example, your apps are growing. You're writing more code. That's great. It can slow down your build a little bit, but that's not the lion's share. Turns out that 96% of you use some form of Gradle plugin outside of the Android Gradle plugin, whether it's another Google plugin, a third-party plugin, or even something that you wrote for your own app or your own company. And when we took a look at some of those plugins, they were not all super optimized. There's also a lot of annotation processor out there, and they sometimes lack incrementality. So when you do a tiny change, it has to recompile everything, and your build speed goes away. Some new languages, like Java 8, for example, or Kotlin, can have some impact on your speed. With Java 8, we mitigated some of the impact by merging the dexing and the desugaring together in one step with the 8, and working a lot with JetBrains to improve the Kotlin compiler and annotation processor. There's also some resource scaling issues. If you have a lot of modules, some of the existing resource pipeline is not necessarily optimized. So you can see that that's a lot. And when you add all of this, it can have a pretty significant impact on your build. And to top it off, a recent survey that we did showed that 60% of developers either do not analyze build speed at all or do not know how to. So there's definitely an awareness problem as well around what can cause delay to your build. All right, so what can we do? Well, first, I want to recognize that some of what I just mentioned comes directly from us, Google at large. And we're really serious about improving this. We're taking steps internally to improve existing features, as well as the new one. But as I mentioned, there's also an awareness problem and tooling issue. And we want to launch new features and new attribution features that can help you better understand what's going on with your build and what is really impacting your build. And we'll cover this in a little bit. We're also really doubling down on performance features, working together with Gradle, and there's a lot of new features that I'll let Jerome, Chris, and Izabela share with you.
Thank you. All right, so let's get started. What did we add in the latest 3.2 release? So the first thing I want to talk about is incrementality in an annotation processor that Leo alluded before. As you probably know, Java C and even Kotlin C has been incremental for quite some time. However, if you have annotation processors, all of this incrementality goes out of the door, and so it's a big problem. And so it has enormous performance ramifications because when we look at our internal dashboards, we can see that the JVM bytecode production tasks are the most consuming task of our build times. So basically being non-incremental is a huge problem. So Gradle, with Groupon and with Google, has come up with InCap, which is aimed at making annotation processes incremental. Now there's really two levels of supports that we are aiming for. The first one is called aggregating, which basically means that if you change a class which is annotated with an annotation of interest, we will have to recompile all the classes which are annotated with the same annotations. So it's not exactly incremental, but it's better than recompiling everything. The other one, which is called isolating, which is much better, much more fine-grained, will allow you to recompile only what has changed. Right? So there's these different levels of support. What is important to realize for some of you is that if you have annotation processes yourself that you developed in-house, it will be your responsibility to make those annotation processes InCap compliant. We are working hard internally to make the most popular annotation processes InCap compliant. So we're going to do Dagger, and we're going to do data binding and all this kind of stuff. But if you have your own, you're going to have to work on it yourself. And if you don't, we also plan to make it very, very clear that if we have to revert our compilation to not be incremental, we were going to make it very clear which annotation processes are forcing us to not be incremental. So if you're providing those, expect to have some bad publicity coming from us saying, yep, we are running non-incremental because of those annotation processes. The second thing I want to talk about is App Bundle. So you must have heard about it by now. In the past, when people wanted to reduce the APK size, they had to do multi-APK, which resulted in a lot of manual steps related to deployments. It was very complicated. So now what you can do is basically create this app bundle, which is a glorified zip file with a universal APK in a specific format, which cannot be immediately installed on a device, but can be used by the Play Store to pre-create all these different APKs for all the different devices that you're targeting. So you've got fast delivery, all this nice feature without having to do it yourself. Now, one of the things you need to understand as a developer using the Android Gradle plugin is that there are things which have changed because of that, right? For instance, you can define, if you use Modularity and you have feature modules, for instance, you can define a number of things inside those feature modules, yet the base module is the one that will actually be providing some information even for the feature modules. So, for instance, the application ID, the version code, soon the signing information, all of those comes from the base ID. In theory, we would want to reduce the DSL per module type so that you could only provide on the build.gradle of each of these feature module the exact information that we know we will be using. But we don't have time, so it's the same DSL everywhere, and you have to be aware that some of it will be ignored in the feature modules. Also, for instance, the mapping file for bundle file will also be for the base module. Now, when you add modularity inside your application, it's relatively easy at the build level. All you have to do is to use the right plugin, as I described in this slide. In the base module, you have the base functionality, and then you apply the application plugin, which you have used for years. In the feature module, you can apply the dynamic feature. Now, we have to declare a special dependency from the base module to all of the different features. And I will explain you later why this is necessary. But this is something that you need to understand is that obviously you have a dependency from the feature module to the base, but you also need to make a dependency from the base to the features. So as an example here, we've got the code shrinking flow. And I'm going to show how this changes when you start introducing feature modules and modularity inside your application. So here you've got a simple example. You've got a base module. You've got 3 feature modules, module A, module B, module C. So far, nothing too specific. Of course, each of these feature modules depends on the base. Now, by adding this DSL declaration, we are declaring now the dependency or the fact that those module A, B, and C are feature modules. Okay, so far simple, but you can see that now we have this dependency going both ways. So when we go through the build flow, the first thing that we do, obviously, is that we build normally all the Java source files. We compile all the Java source files into classes.jar, That's so normal. That's the normal process that we go through when we build each of these different modules. But the thing that really starts to differ when you're dealing with feature modules is that we are publishing back all of these jar files back to the main module. And that's absolutely necessary because when we do the code shrinking, you need to have a global view of the application. You can't do a shrinking just on the feature module because you will not know how and what they use of the base classes, for instance. So once you have those published to the base, you can feed it to the shrinker and the splitter, and eventually it's going to create equivalent DEX files. As you can guess, there is more or less a one-to-one mapping between the original jar file containing the class files and the DEX files containing the DEXs, but it's not exactly a one-to-one. So for instance, let's say that you had classes that were in your base module that you thought would be shared by different feature, but only end up being used by, say, module B, then it's perfectly legal for the splitter to decide that he wants to move those classes into the dexb.jar instead of keeping them inside the main dex.jar of the main module. But otherwise, you can more or less imagine that there is a one-to-one mapping. So once this is done, you've got all these DEX files which are still residing in the base module. Now they're going to flow back into the originating module, dynamic feature module. And we do that so that you can have as much parallelism in your build. So as you can see, at the beginning, we had the compilation happening in each of the submodules. It was potentially parallelized. Depends on the machine you have. But if you have a powerful machine, all of those would run in parallel. Then we moved everything to the base. Then it becomes kind of a bottleneck for the build system because it has to wait for all the modules to be ready to be able to do the shrinking. But once this is done, we can move back the processing to each of the submodules. So you can see that adding modularity to your application may be a good software practice, but it's also a good practice in terms of the build, because we're going to get much faster over time. We move as much stuff as we can towards the leaves of all of these modules, and we can run all of those in parallel as much as possible. Once this is done in parallel, once this is pushed back to each feature module, we can then resume the normal processing, and eventually we will create all the necessary APKs or all the necessary artifacts to be able to create the app bundle. All right, so all of those, again, is in parallel. Now, obviously, the shrinker, the fact it's a little bit of a bottleneck, like I explained earlier, is usually not a problem because, not a problem for debug build at least, because usually people do not use shrinker, code shrinking during the debug builds. It's only done for the release builds. But we really try to limit these bottlenecks as much as we can, and Chris will explain also how we have enhanced a lot the resource processing with this type of improvements. Another thing that we added in 3.2 was D8. So D8 is the new JVM bytecodes to DEX file translator. We will eventually remove the old one, which was called DX. If you're still using DX, you really need to start panicking because we are going to remove it. And once we removed it, you will not be able to upgrade any longer. So if you are using DX because you have issues with D8, you must file a bug immediately and follow through to figure out what is wrong, if it's with your build or if it's with D8 itself. Otherwise, you're going to get stuck in the past. Our 8 is going to follow more or less the same path, meaning like it's available right now to try. We are very happy with the results we are getting so far, so it's very stable. You should definitely try it. Eventually, it will become stable. And you can guess what's going to happen to the old code shrinker, to ProGuard. Eventually, we will also remove it and completely replace it with R8. If you want more details, there is a session tomorrow that will give you a lot more technical details about how these two libraries are implemented. OK, let's talk a little bit about what's next in 3.3. So the first thing I want to talk about is lazy tasks. So Gradle has introduced the concept of lazy task, and a lazy task is, you should really understand it as a task that will only get initialized and configured if it is on the execution task graph. So that means, for instance, if you've got, let's keep it simple. You've got two variants, the debug variant, the release variant. If you're calling assemble debug, there's no need to initialize or to configure any of the tasks related to the release variant. And so what we used to do, unfortunately, so this was done before in this particular example where we used to create all the tasks. We still have to do that. But at the creation time, we were also configuring them. So we were ending up configuring all the tasks for debug variant and all the tasks for release variant, even though only the debug were eventually going to be executed. With lazy task, Gradle is giving us the tool to basically delay all of this initialization until it knows that those tasks will be executed. Now, when I say executed, it's not entirely true, because what it really means is that it's going to be up-to-date checked, meaning it's going to look if the task needs to be run or not by running its up-to-date checks. But potentially, at least the task is on the execution task graph and may be executed if it's out of date. So how do you do lazy tasks? It's basically very similar to the old style. Instead of doing create, you call register. But you can see that now the configuration code, which is in blue here, where you initialize the input food value, will only be called if the task is on the execution task graph. Now, we used to really pay a lot of attention for all of our configuration tasks to make this configuration block as lean as possible, because they were always executed. So if you were to do Gradle tasks, it would always execute all of this configuration. So we try to keep it as lean as possible with no access to disk, no access to network, for instance. Now, it's probably a little bit more OK to do more work in those configuration if you really have to. But you have to remember two things. First, if you do real work, it will still impact your build time, because the configuration time is still a mono-threaded event in Gradle, meaning all of the configuration will happen one after the other. So the more you do, the longer it will take. And you already know today that configuration time happens all the time. It's very annoying. We are really trying to reduce it to the bare minimum, but any time is really annoying. The second thing is to not look up tasks anymore. So when you have build.gradle customization, a lot of people are doing project get task by name or kind of stuff like that. This will actually look up the task and initialize it and configure it. And if you do that, it will not only do that for the task itself, but all of its transitive dependencies as well, all the tasks it uses and all the output and all this kind of stuff. So you basically have a good chance of initializing the entire world. Instead of doing that, you should get a provider and get a lazy object of the task itself and use that to register your dependency. Now, what you can also do if you want to have access to the output of a task is use that provider and map the output using this type of API to get a provider. So it's basically a promise on a folder or a promise on a regular file that the task that may execute will give you later. You can see how the level of interactions you're getting here. But eventually, it will give you the idea that you can get an object which represents the output of a task. And that object does not initialize the task itself. Getting this provider does not initialize the task, does not force it to run, and it's really lazy. And it contains also the dependency information. It means you don't have to register yourself as a dependent of the task producing this output folder. Just holding the object itself, the provider, will allow you to not only get the object, but also register your dependency on whoever is producing it. Eventually, you can do a get, and that will give you the actual task, the actual object that you can use to configure your own task. So here, when bar is getting configured, foo gets configured, and eventually all the dependency of foo will get configured, and so on and so forth. So you can see how lazy this is becoming. We are retrofitting all of our tasks to become using providers and stuff like that. So if you use customization a lot, you really need to look into these new APIs in 3.3. And now Chris will talk about some of the other improvements we've made.
Yeah, so another optimization to the build process coming up in 3.3 is light R classes. So previously, the Android Gradle plugin would generate an R.java for every single dependency and every subproject, and then compile them alongside your actual classes. In Android Gradle plugin 3.3, it just generates a jar containing the class directly. Especially for builds with many library subprojects and lots of dependencies, this avoids a lot of compilation, a lot of I/O. For some large multi-module builds, we actually saw double-digit percentage speed-ups when building from clean due to this change. So the R-class system in Android Studio 3.3 has been rewritten to simulate all of these R-classes in memory, rather than relying on the ones on disk. Happily, this, as well as enabling this optimization of the build, it actually speeds up indexing in Android Studio as well, even for projects with older Gradle plugins. This does, however, break some Gradle plugins that depend on reading that R file directly, including Butterknife, which I'm working on fixing. And it's implemented for libraries in 3.3, and we're working on implementing it for applications and tests too. As Jerome mentioned earlier, Gradle now has support for incremental annotation processing, but it does need support from the annotation processors themselves. And yeah, he said that we're working to support the most popular annotation processors, including Dagger, Room, Glide, AutoValue, and some others. We're also working to re-architect data binding to allow it to be an isolated annotation processor, speeding up your incremental recombination even more. We also want to help you understand that build time impact of annotation processors. So we want to report to you like which annotation processor was time spent in and how much did they cost. On that theme, there are several other areas we want to give you better insight into your build, easily and simply. So yeah, if you're using annotation processors, that's really critical that you have that insight, because they're often a bottleneck for internal builds for a lot of builds that we see. When a Gradle task causes you trouble, it's really helpful to know the Gradle plugin or the script where it was created and what triggered it to run. And we're working to make finding that out more easy.
We have time. You can take your time.
We also want to help you find these types of issues, even if you're not actively looking for them. So longer term, we want Android Studio to flag if there is an issue, or if something changed and regressed. And we'll point you towards the Gradle build scan, which is a powerful tool for getting a bit of insight into how your build's working. OK, so on from these kind of better insights to complete rewrites, Android resource namespacing. Resource namespacing is a completely new pipeline for compiling and linking Android resources. So we're actually doing this for two reasons. Firstly, speed up the build and make it easier to understand. And secondly, we want to better support dynamic features. Looking at how things work now, in the existing resource pipeline, there are two namespaces, the Android platform and everything else. That means that if you have two libraries that define a resource of the same name and the same type, the resource manager has to pick one. And it's not always clear what the right thing to do is, or even that this is happening at all. This actually also makes splitting your APK up into several dynamic features much more difficult. As each dynamic feature is shipped separately, where those resources come from and where they go is really important. So with resource namespacing, each library is compiled and linked separately, and then linked together into the final APKs. The R class in applications will no longer have final IDs. And then when you're using resources from both XML and from Java, you need to be explicit about where they came from. So each resource is only listed in the R class for the library that defined it, and in XML, you need to use the namespace of the resource to refer to it. This also means that resources no longer implicitly override one another just because they had the same name. For cases where you needed these overrides in the application, we're working a new way to do that explicitly. ARs that we generate from namespace libraries will be backwards compatible, so you can have all the benefits of namespacing yourself, but not impose it on your consumers until they're ready to switch. OK, passing on to Izabela to tell you a bit more about the details.
Thank you. OK, now that we know what resource namespacing is, let's move on to how to, in the future, namespace your app or library. You might find yourself asking questions like, where is that resource coming from? Or what is the proper syntax? Or how do I even namespace my dependencies? Well, the answer to all these questions is, we'll fix it for you. So the solution is automatic namespacing, or auto namespacing for short. There are two main parts here. First is the automatic rewriting tool in the IDE, which will help you migrate your local modules to be namespaced. And the second one are the transforms and tasks in the Gradle plugin that will rewrite your remote dependencies under the hood, no actions required. Here is an example dependency graph. The blue nodes are local modules that can be rewritten using the IDE tool. The 3 orange nodes are not namespaced, classic, remote libraries that will be automatically rewritten by the AGP. This means all the resources, classes, the manifests will be rewritten to use the full resource namespace. And finally, the green nodes they represent dependencies that are already namespaced, so they will not be modified at all. Let's see what types of changes we can see after this migration takes place. In the bytecode or Kotlin and Java sources, you can see that now there will be different R classes present. If a resource was defined in a different module or a remote library, you will see the package of the R class will change to match that package. In the XML resource references, like in the values files or in the manifest, you will see the new namespace appear between the symbol and the type of the resource, similar to the Android namespace. And finally, another way resources can be referenced is in attributes, for example, in layouts. Here, the XML namespace will be modified to point to the correct package instead of res auto, and the attribute will use this new namespace as well. And since we're already on the topic of resources, let's talk about resource visibility. So probably many of you created an Android library with a lot of effort into declaring which resources are public, and then published this AAR with the public.txt. Only for consumers to ignore it. This currently is only a lint warning. This code compiles and runs fine at runtime, completely ignoring the intended visibility of the resource. I'm sure many of you actually ignore these warnings as well. Great, so to combat this, we want to introduce stricter resource visibility. So these violations will now become build errors instead, so we will catch them early. And we will introduce 3 levels of visibility. 1, public. This means these resources will be present both in the public art classes of the consumers and the private art classes for that local module. Private resources, only present in private R classes. And last, private XML-only resources. They will be not present in any R classes at all. Instead, they will be only, you can only reference them from other XML files within that module. This will result in smaller R classes, both compile and runtime, and also resource hermetization, similar to the class or method hermetization currently in Java or Kotlin. So with that, Leo.
Thank you. All right, so as you can see, we're working on a lot of things, and many of which we hope would help with beat speed. But going back to my point around awareness and tooling, I want to share some of the things that you can do today to understand your build better and improve its performances. So the first things is to upgrade. If you recall my first graph, we do improve with every release. And so if you really care about your build speed, the best thing to do is to upgrade to the latest stable, beta, canary, whichever you feel most comfortable with. Now to toolings. There's some tools out there that you can start leveraging to better understand your builds. One that I really like is --scan. It's a free tool from Gradle. It uploads some of your build data into Gradle servers, and then provide a very comprehensive dashboards around task durations, plugins, dependencies, and many, many more things. So if you're trying to understand what's going on with your build, why is it slow, this is a very, very useful resource to use. If sharing some of your build data with Gradle is not something that you feel comfortable doing, there's the Postman's version of it, which is --profile. --profile will create a local HTML file that you can open in a browser to show some information about your build. It's definitely not as rich as the --scan, but it provides some information and remains local. You can combine it with --info, which gives you information on why a given task ran. another tip, which is more of a continuous request, is to file bug. We really try to test all of our releases on as many environment and use cases that we can, but there's always edge cases and different configurations out there. So please file bugs when you encounter issues. And when you do file a bug, please include a scan with it. It really helps us go deeper into the issue and understand what's going on. Last but not least, if you're writing plugins, whether it's for you to publish them or even just customize a little bit your build file, here's a set of tips to follow. So first, as Jerome alluded to, configuration is really just to set up tasks, not really do anything else. And as was mentioned earlier, remember, if you need to compute things for up-to-date checks, you can always use provider and suppliers to only run those checks if your task is part of the active graph. For example, in configuration, you should not do things like query git, read a file, search for a connected device, or compute anything. Configuration is really just a place to set up tasks. And it's the place to set up all tasks. Because build doesn't really know what path is going to take in advance, so really try to set up all of your tasks in the configuration step. Regarding tasks, make sure that each task declare all input and outputs, even if it's non-file ones. And make sure that they're incremental and cacheable. If you're working with a complex step, try to split it into multiple tasks. This really helps with the incrementality, because some tasks could be up to date, while others do work. And if you have multiple tasks, they could run in parallel. So it helps with incrementality and parallelism. This third best practice sounds obvious, but I still want to put it out there. Just make sure your tasks don't write into or delete any other task output. When you write tasks, use Java and Kotlin instead of Groovy, and put them in a plugin/build.src folder. And last but not least, as you've heard from Jerome, leverage the new worker API. Oh no, we didn't talk about this.
No.
Oh. But leverage the new worker API.
I did talk about parallel stuff, though.
Yeah. That really helps with parallelism. All right, if you didn't get clear pictures of all of what I just said, don't worry. We're working on a full write-up covering everything that we talked about around speed, around the findings that I shared, the tooling, the best practices, and more. So stay tuned. To recap, here's the takeaway from this session. First, we shared some finding on speed, and that we're basically a little bit outpaced by some of the features, the plugins, and all of the other things that are impacting build speed, but we're taking this very seriously. And so we're doubling down our effort on better tooling and attribution that you heard, as well as continuing to improve performances. We share the new features in 3.2, and I definitely encourage you to upgrade to 3.2 if you haven't already. And we mentioned some of the things that are working for 3.3 and beyond. And by the way, 3.3 beta is available, so I encourage you to try it. It has some of the things that we mentioned, like lazy tasks and others. And last, I talked about some of the tools that you can use, --scan, --profile, today to understand your build, and share some of the best practice if you're writing plugins or customizing your build speed. That's it for today. I want to make a bad joke, but unlike build, we finished earlier than expected. So